Welcome to Schweitzer Drive, a podcast where we explore what goes on between the generation of electricity and the light switch. Join Dave Whitehead as he interviews the entrepreneurs, innovators, and experts who are inventing the future of electric power.
Hi, I'm Dave Whitehead. Welcome to Schweitzer Drive. Today, we're continuing our discussion regarding wildfire challenges. Whether it's preventing power lines from causing fires or keeping the lights on during extreme conditions, utilities are working hard to protect both people, property, and infrastructure. Joining me today is James Tuccillo, Manager of Distribution and Asset Planning at PG&E. We'll discuss the utility's strategy to reduce wildfire risk throughout its northern and central California service area. With 15 years of utility power system engineering experience in roles of increasing leadership, James has built a strong foundation within distribution operations and engineering. After spending his first half of his career in control center operation, he now manages the distribution engineering team at PG&E. This team is responsible for the capacity and reliability assets, planning, as well as distribution protection. James currently serves as the lead engineer on PG&E's Enhanced Powerline Safety Settings Program, a critical initiative to mitigating wildfire ignition risk on the distribution system. He is passionate about building teams and developing the next generation of engineers and leaders to ensure the electric grid can safely deliver energy and meet California's energy goals. He holds a bachelor's and master's degree in electrical engineering from California Polytechnic State University, San Luis Obispo, and is a registered professional engineer in California. Hi, James. Welcome to the podcast.
Hello. Great to be here.
I'm so looking forward to this. You know, we've done a number of, projects together down in your service territory. You guys are probably, I would say, one of the leaders when it comes to wildfire mitigation and detection strategies. So again, looking forward to getting into this. But before we do that, will you tell us about your background and how you became interested in electrical engineering and electric power?
Yeah, thanks, Dave. Yeah, that's a great question and a kind of an interesting story. I think as a kid, I would say my parents saw kind of those leanings from a young age. My family background was actually in gardening and landscaping, not too electrical involved there, but I really enjoyed working with my hands on power tools, lawn equipment, motors, kind of taking things apart, rebuilding them. And that's kind of where the passion started, I would say, from an engineering standpoint. As I got older, I developed an interest in playing, musical instruments, guitars, and things like that. And so that kind of put me down the electrical path. I was really kind of nerdy with guitar pedals and wanting to, build my own electronics for that purpose. And so that's kind of what, pointed me towards electrical engineering. I applied, for a couple universities and got accepted here to Cal Poly in San Luis Obispo, which is actually my hometown since I started college. And I've really developed a passion and love for the electrical power industry. I actually interned with PG&E in Oakland while I was still in school. And I thought at the time I wanted to actually go into computer engineering. I was kind of on the fence. I just applied for a few internships and, had my first internship in distribution planning, kind of at the grassroots of the distribution system, and fell in love with big power. Standing right next to large power transformers in the substation. Feeling the importance of the job. And keeping the lights on from anywhere from going into your Costco. And seeing, how much economic activity occurs in a space like that to serving, rural communities. All those aspects were really important for me to be a part of. So that's kind of where I started. After school, I actually spent some time in nuclear industry. I spent time at SCE's nuclear plant down in Southern California, as well as some time here at PG&E's plant. I thought that was going to be it. I thought I was going to be nuclear engineer for my whole career, but things changed. Opportunities came back open in actual control center operations, engineering, real-time engineering, and I took that opportunity. And that was a great time too. That's where I spent better part of 8-9 years. But that was really a special time because I got to see how engineering decisions and analysis that we do happens in real time. And so the feedback loop is very short in operations. You make a decision, you perform an analysis, and like the next hour, it's being implemented in the field. And I found that a very beneficial way to learn kind of the nuts and bolts of power engineering in a way that the nuclear plant didn't totally afford me, because there's a lot of regulations, obviously, and a lot of checks and balances that are needed in that industry. So you don't learn to get that instant feedback in the same way. So that's a little bit about the background. Kind of the irony of it is, a lot of folks say now, the corporate risk structure used to be for utilities, a bad day at the nuclear power plant was kind of the highest corporate risk. Now it's actually changed. It's really this wildfire topic is one of the highest risks to utility operations. So it's kind of an interesting full circle from the original days in nuclear.
Now, just a little side note, are you still living in SLO?
I do, yeah. Still living in San Luis Obispo.
That's really cool. So you're living in your college town. I'm living in my college town. It's kind of a special thing. I think we're unique in that way.
It is. One interesting thing too I didn't mention was actually Dr. Schweitzer came out when I was in school and did a talk. I think I was a junior at the time, and I found it very inspiring. I don't think I knew for a fact I'd get into power systems engineering at the time, but I do remember attending his talk, and just very breakthrough mindset. Very much, let's come together and solve tough problems. And I won't forget that speech that he gave.
He gave a talk at one of the IEEE meetings when I was going to school here too, and I don't remember exactly what it was. I'm sure I went for the free pizza or something like that. But I do remember him saying something, this is better than canned beer. And I'm sure it had to do with microprocessor-based relays at the time. But I had the same experience listening to that when I was in college. But moving on a little bit to the wildfires and why we're here today, can you walk us through the key strategies PG&E is implementing to mitigate wildfire risk? And I'm sure we probably only have a half hour or so, and that this discussion could go on for 6 hours, I bet, with all the things you all are doing.
Sure, yeah, it's been a journey, and I'd be remiss not to mention, while this started out as a California issue, right? It's now affecting areas from as far as Hawaii to the East Coast to beyond, really. It's a worldwide challenge to solve. But here in North America and the U.S., we've seen the devastation, right, that can occur when utilities are faced with this challenge, be it from changes to climate or to forest practices, et cetera. There's many different variables involved. But, the campfire for PG&E was a pivotal moment. We had 85 lives lost as a result of that event, and it shook us all to the core. I was working at the utility during that time here. The tragedy of that event really set into motion a new way of thinking and problem solving in this space that I'm reminded how important every day the work is that we do. And if we show up well and we pursue strategies and technologies that will make a difference, I can go home and sleep better at night. And so part of that, it's very multifaceted, obviously. Undergrounding, you've probably heard, right? That's a core strategy. I think we'll talk a little bit more about that shortly, but undergrounding is a huge component of the way we're attacking wildfire risk. In addition to that, overhead system hardening, be it covered conductor, strengthening poles, insulating against animal contact, those kind of things are a big part of our risk mitigation. Our enhanced power line safety settings program, that's what I'm the most passionate about and most directly involved in. That's made a huge difference in immediately reducing risk on our system.
Hey, James, real quick, what is the power safety settings program for our listeners?
Yeah, enhanced power line safety settings. That's the term we use to describe the posture in which we place our protective devices, equipment, relays, etc. in when the weather conditions warrant it, basically. So in California, we'll start seeing drying conditions typically in the late spring, about this time in May, June. And as summer progresses, those fuel moistures and humidity continues to decrease. And what that basically means is the vegetation and the environment is much more easily ignitable. So our power line safety settings program responds to that increased risk by doing a few things. One is speeding up the clearing times and tripping of protective equipment, but also disabling reclosing and adding on additional layers of high impedance fault detection. So that's essentially the main components of our power line safety settings program.
So the way I sort of think of it, and you can correct me if I'm wrong, is during, let's say, February or some kind of wet season, you guys can focus on reliability, keeping the electricity on, as much as possible. And as things start to dry out, your focus probably shifts to more of a safety posture as opposed to avoid lighting fires, not no matter what, but certainly trying to reduce the chance of a fire starting because of a down conductor or something similar.
Exactly. That's correct.
You mentioned about the undergrounding, and I understand that you have a massive effort to underground 10,000 miles of power lines. That's probably the biggest undergrounding project in the U.S. that I've ever heard of. Can you explain the reasons behind it, maybe a little bit the economics of it, and how you might decide whether this overhead or line should stay overhead or whether it's better to go ahead and underground it?
Sure. Yeah, this has been indeed a huge undertaking and a very bold position. I give a lot of credit to our executive leadership for taking this position. Just a couple facts with the program, since you asked. We have made that claim of 10,000. It was kind of back in July of 2021, pretty much on the heels of the Dixie fire event, second largest fire in California. And since then, we've completed from 2022 to 2024, 800 miles of underground. So a significant accomplishment for the team there. When we began the program back in 2022, we were doing about 180 miles a year. In 2025, we're actually targeting 310 miles. So we've significantly ramped up our capability to get to that objective. We believe we can actually get to 400 to 500 miles per year, depending on how far in advance we can kind of stage that work. So these are really industry, precedent-setting numbers in terms of capability, especially in the California environment, which is, it's challenging from a permitting, from an environmental standpoint. There's lots of steps to take in going to underground, and so depending on how successful we are with planning, getting multi-year programs in place to get ahead of those challenges, we can be more and more successful in getting to the higher numbers per year, which will allow us to achieve our goals.
What is the voltage level that you guys are varying? Is it just 13.8 or higher?
Yeah, it's mostly 12, 12.47 kind of voltage class, as well as 21 kV or 25 kV voltage class. Those are the two main ones. In typical distribution systems, we're used to seeing power poles and power lines, and obviously a utility has a right of way to put those distribution lines through those pieces of property. So utility already has access to the property, if you will, through easements and whatnot. Why wouldn't you underground everything as opposed to, if it's so much safer and so much more reliable, why not just bury every single distribution line we have in a community or in a rural area? Sure. Well, we've actually, started to take some steps towards that end. We do bias ourselves towards undergrounding now in the highest of risk areas. But, the underground solution, while very effective at reducing ignition risk and keeping that part of the system safe, there are undergrounding challenges as well. Obtaining those easements, land rights, making sure we can actually dig in the ground. Some of our areas are solid granite. So it's just getting a trench into the ground is not even feasible. So we look at that when we scope out those projects. We look at,
what about the cost side of it?
Yeah, the cost is incredibly substantial compared to overhead. The number changes every time I hear it, but it's at least 3 to 4x what would it be to rebuild an overhead line. But those costs for vegetation clearing are substantial as well. So that's the part that, from an economic standpoint, is starting to change the equation. Is the cost of vegetation management that we're incurring is actually making the economics of underground much more favorable.
Actually, not to get into the economics of a utility, but I bet undergrounding something could be a capital cost and vegetation management is an O&M cost, right? And
that's correct.
A utility would much rather have a capital cost than an ongoing maintenance cost or something. So
sure.
I
and a more reliable system.
Oh, too. Sure. Absolutely. I was just doing the accountant side of it, right? Going, maybe undergrounding is a better long-term deal for the utility than the overhead side. Increasingly, utilities are using public safety power shutoff or PSPS as a tool during times of high wildfire risk. Could you discuss PG&E's approach to PSPS?
Sure. Yeah. PSPS or public safety power shutoff, that's what we see as a continuum. It's pretty much the last step, right, in terms of risk mitigation. It's a measure of last resort, basically when the wind conditions would likely drive any ignition to the size of a catastrophic event. So it's not something we take lightly. Obviously, shutting off the power proactively can have its own set of safety risks that need to be balanced in the decision. For example, critical medical, baseline customers, essential services, water, fire, et cetera, are all impacted by that. So it's a program that we don't like to implement, but we will if we have to when the conditions warrant it. Since we started first doing PSPS, the first few events were in 2018 and 2019. We de-energized upwards of 2 million customers in 2019 alone. One event actually had 1 million customers impacted. We've done a lot of improvements since then, come a long way to reduce that impact and the footprint. A combination of things, better meteorology models, increased sectionalizing. We've installed over 1,300 new remote controllable switches or reclosers to further segment the system. We added about 1,700 SCADA radio systems to existing equipment to get the ability to de-energize remotely. So we've made a lot of improvements to minimize the disruption that causes to our communities and customers. And as a result, what we would expect for that same 2019 event, which was a pretty severe meteorology event, we would see half of the customers impacted for that event. So we've taken a lot of steps to refine the program. There's still more work to be done, more continuous monitoring, more weather stations, smaller, more focused meteorology, targeted modeling. And then the big thing that's come up more recently is along the lines of transmission induction risk. So you would think that you could just de-energize your transmission lines and reduce risk that way. But as we've experienced and as happened in some of the other parts of the country, de-energized lines aren't themselves totally safe either. There's other risks to contend with there. So while we have a lot more to do around PSPS, I feel like we've really made some great progress since those early shutoffs back in 2019.
Yeah, I don't know what the final outcome was, but SCE had a challenge, right, with induction from a de-energized or unused line with some overhead lines that were still active, inducing voltages on the cable. It's something probably you don't think about every single day, right? But there's certainly an impact to that. Hey, getting back to the SPS conditions, I would imagine that there's a set of group that is always, I'll use the term unlucky when it would come to being turned off, just because of the location they live in. It's out in the back country or something like that, and in a dry area. But then I also got to thinking do they have their power interrupted just because they live in the back country? They probably have a lot of vegetation around, and the wind does blow, whether it's dry or wet. And, that certainly overhead lines are susceptible to lines getting knocked down for whatever reason. So I'm wondering if this particular population has probably bought generators already to install in their system, not only for when there's a high fire risk, but just for life in general. Is that the case or not? Or I guess, man, you're talking 500,000 people now, so that's still a lot of people and would be a lot of generators. But
yeah, we've actually been able to work pretty closely with our communities to develop some programs where we can actually supply generators and different tools to supplement their reliability needs, both in the winter season as well as in, kind of this wildfire posture. And that's really because it goes back to the undergrounding plan, right? We really see the undergrounding as the, final solution for a lot of these challenges. We've done remote grid deployments, some microgrid, kind of the end of the line, supplemental standalone power systems. But the underground system is really the best way to reduce the risk on the system, and the reliability improvement that it provides is substantial. Vegetation is also, right? So there's a joke, right, that we're Pacific Gas and Electric and Vegetation Management Company. One interesting stat is, we spend about $1 on average of a person, a customer's bill on undergrounding, and we spend about 20 right now on veg management. So the cost of doing vegetation management is very substantial. So getting the power lines undergrounded is very important to help reduce those costs and invest in a system that, frankly, be more reliable.
That's a really interesting statistic. I hadn't thought about it. Now, I'm sure that vegetation number comes from your whole service territory also, right? Which is huge. But that's interesting. How is PG&E working to ensure the resilience of its infrastructure against the increasing frequency and intensity of wildfires?
Yeah, we talked a little bit about this. Obviously the underground program is the core strategy. Some of these standalone power grids and microgrids, or sometimes we'll call them remote grids, these are an increasing tool in our toolbox to be able to segment off long stretches of overhead lines that, if we were to have to underground or rebuild, would be extremely costly. So by installing a solar and battery system with some supplemental natural gas generation, typically, or propane, we're able to basically take that section off the main grid. It doesn't fit every situation. There's some situations where the load demand is not economically, able to be provided in that manner. But we do look at that and take those opportunities when we can. The interesting thing too is with where things are going with electrification and EV mandates in California, we're also at the same time doing a lot of capacity work. So we're increasing capacity of our substations, installing new circuits, reconductoring, et cetera. So when we look at those improvements in wildfire risk areas, we really look closely at the opportunity to bundle in undergrounding into those plans, so that we can satisfy kind of our wildfire risk, but also build in the capacity needed to serve these new higher demand loads.
Now onto the technology side of things. What technologies or innovations is PG&E leveraging to mitigate wildfires, maintain power supply, and minimize disruptions during wildfire events?
Yeah, this is the fun stuff for me here. So I think, we've mentioned the Enhanced Powerline Safety Settings Program, EPSS. A little bit of a background on that. So in 2021, at the heels again of the Dixie fires, when that program started, and what what we observed in that event is basically it was a clear, low wind, a nice warm summer day that ultimately became the second largest fire in California history. So it wasn't a day where the winds were howling, where the Diablo or Santa Ana winds were in full effect. It was a pretty peaceful, calm day, but the field conditions and the topography was just right, to allow that fire to really spread. So we realized very quickly that we needed a new approach to manage our protection posture that was heavily biased to reduce the ignition risk potential on the system. So it was more targeted for just reducing overall counts of ignitions rather than reducing the risk of a catastrophic event. So that's where the EPSS, or the Enhanced Powerline Safety Settings program, was born. Interesting about that fire too is it was a high impedance fault caused by a vegetation contact to the 12 kV distribution that ended up blowing one of 3 fuses. And because of that, we went into what we call a high impedance backfeed situation through a service transformer winding. And at the initiation of that event, we actually did get a overcurrent pickup at the substation. So if we would have been able to catch that first stage of that fault, we probably would have prevented that fault from persisting for the several hours it did before the fire actually ignited and really took off. So looking at that event, looking at similar events we had seen previously, we developed this posture where we actually, proactively overreach fuses. We try to get gang operated tripping, and we reduce our clearing time to either 6 cycles or less, or I should say our relay response time to 6 cycles or less. And then we also add in additional layers of high impedance fault detection through what we call our down conductor detection program. And so this is really the main strategy we have now to deal with the dry fuels, kind of when we're not necessarily at that level where PSPS is needed.
I've seen a lot of different studies from folks with trying to test out new algorithms with down conductor, and part of that was doing stage faults. And I think I was watching videos from you all, right, where you'd hang like a pine tree across a wire. Was that you guys that I'm remembering?
Yeah, that's correct. Yeah, we.
You want to describe
spring.
it? It was fascinating, right? Because the fault just doesn't happen. It takes minutes to hours for these things to actually start catching on fire and burning. It's fascinating.
Yeah. Yeah, we had the opportunity actually in conjunction with our engineering partners at Schweitzer R&D to do some proactive staged fault testing on our live system. So this is on a system where we're serving load customers, but it was in this early spring when it was actually raining and hailing while we were out there, ironically. But it allowed us to be able to stage these types of high impedance faults so we could better learn about their characteristics, and then be able to rapidly incorporate the learnings from that into new strategies, algorithms, et cetera. And one of the most interesting takeaways on that is that, you hear the term, right, arc sense or arcing fault detection. It's actually not about arcing. For vegetation, it's really about finding these slow, like leaks in a pipe, basically, like little drips of power flow that are leaking out of the system, and trying to count those drops and develop a protection measure that can detect that very hard to detect situation. The good thing is I feel like we made some great breakthroughs that during that week of testing. We've developed some new insights that are now in the process of being incorporated into some solutions in partnership with SCL. So we're really excited to put that online on the system this summer.
Yeah, and for everybody listening too, that one of the real big challenges when we talk about these high impedance faults is you have a distribution feeder that's serving households or plants like ours that I'm sitting in, and they're this feeder may be carrying hundreds of amps, and as James pointed out, there's just this little trickle of current, maybe an amp or something like that that's as he said, dripping out of the line through this I don't know, a tree that's fallen on the line, right, causing that high impedance fault. So trying to detect this point, this 1% change or something like that. And from the relay back in the substation, you don't know if that's just more load, somebody's water heater turned on or something like that, or it is a really, really difficult problem. A line to ground fault that's pulling lots and lots that's easy to detect. So the challenges that James and his team and some of our folks that are fortunate enough to work on with him and his team is these are really, really hard problems. People have been trying to solve these things for, years, ever since I joined this industry over 30 years ago. So.
Yeah, I think the big difference that, I'll mention is, as opposed to these kind of previous efforts to solve this problem, first of all is the use case, right? Wildfire mitigation is really a newer use case for this type of technology. And then the other part is, what we've done is basically utilize what's available in the industry and what exists today and actually turn it on the system, not only just in an alarming capability, but actually in a tripping mode. So you learn very quickly, by necessity, how to prevent and how to improve things when you're actually, in a mode that you're potentially interrupting customers.
Oh, sure.
So it kind of raises the table stakes a little bit to be a little bit more biased towards action and improving these types of methodologies, because if something operates unnecessarily, it's really affecting customers. But the great news is that since we've enabled this, we've seen substantial reductions in ignitions. Just the EPSS program alone, we've reduced our ignition counts by around 65%. So
that's huge.
Since 2021, 65% down. Each one of those are potential, large fire starts across our territory. So we're really proud of that. The hard part's been the high impedance. That continues to be a challenge. 50% of the ignitions that get through the cracks of that protection are high impedance. And so that's why we really are focusing on this problem now specifically to try to find novel ways to solve this.
Well, I think you guys are headed in the right direction. So that gets to my last question. What is next in the realm or the science of high impedance or wildfire mitigation techniques?
Yeah, it's a great question. Well, one of the things, I'll tease out a little bit is part of the work we're doing with SCL in collaboration with PG&E is to think about new strategies around this type of problem solving in that, typically the thought is these types of high impedance algorithms, will reside on a traditional protection relay. And kind of what we learned over the last few years is a couple things. One is that this stuff will change, right? You will learn and you will kind of goes back to the operational days where I said there's a quick feedback loop, right? And protective relays are really good at doing their core functions. And that really hasn't changed for many, many years. Like a distance element, probably not going to change too much, over the years. But these algorithms will change, guaranteed. And so what we need is a platform to be very nimble and iterate, on improvements and be able to make changes, adjustments, and push that back out to the field, very quickly in a very short feedback loop. So the introduction of computer capabilities into protection systems has really allowed us to start to realize that as a benefit, where we can, just like your iPhone, right, push a new app out to your protection system without having a lot of complications and needing to regressively test a bunch of standard protection elements that didn't change, right, with that change. Those are the areas where we're really excited to start leaning into, along with the algorithms themselves. So the platform, computer-based platform, running a host of algorithms, because the other part of what we've learned is that these types of faults, they evolve. They're very dynamic. They start out one way, sub 1 amp, and they have different stages as the vegetation dries out and carbonization occurs. So you actually need multiple safety nets kind of in place to be able to try to catch that event before it really starts to become a sustained ignition. So the computer kind of allows many different levels and layers of defense kind of all on one platform. And then the final thing is what it has is great is a very high amount of storage capability. So these events, like we've said, they could take hours to evolve. And to really understand and make improvements to the detection, you need to have that whole data stream from the very beginning of the event to the end. And so having a very large recording capability for high sample rate is really important. So that's probably the most exciting and kind of futuristic aspect that we're leaning into. And then the other big game changer I'll highlight is, and I say this as an electrical engineer, but I believe also the future is more mechanical based sensing. There's a couple different companies now, one in particular, Gridware, that's partnering with us in installing pole mounted sensors. And so these sensors can detect vibrations, tilts, audio, magnetic fields, E-fields, you name it. They have a lot of sensing capability. And the nice thing about these sensors is they tell you right where to go, right? They know where the problem is because they either felt it, they heard it, or, they've inferred it through indirect measurements. So the best we can do electrically, usually we can get a couple, maybe within a mile or so, maybe half a mile. But with these physical sensors, you can get right to the damage location.
Yeah.
And that can help us prevent ignitions. That can help us get the power back on faster. So we're really passionate and excited about that. Also, as a futuristic solution, we have 10,000 of those sensors installed on our system today. And we're looking at more use cases for that, as well as potentially even tying that into protective tripping in a closed loop fashion. So that's also very exciting to me. Again, as an electrical engineer, we like to harness as much as we can from the electrical equipment, but the mechanical space, the physical space of these pole-mounted sensors is very exciting, and I believe will be a big part of the future of wildfire mitigation.
I was looking at, I think in the Northwest we call it the risk of fire, right? And they were showing the West Coast. Actually, it showed the whole U.S. and where the fire danger zones were. And of course, the usual suspects showed up. It's all up and down the West Coast, but it goes into the Northwest, deep into Montana, like halfway across, where it gets to all the way through the Rockies to the plains and stuff. So they're predicting, certainly for us on the West Coast, and I think Texas had some hot spots too. Probably a dangerous fire season for us this year based on predicted precipitation. So what would be fun to do is get back together with you in the fall to see how everything worked out for PG&E and the successes you've had by then. So I'm gonna call you up and see if we can get you back on in I don't know, September, October, November timeframe, and let's talk about how 2025 went.
Yeah, I'd love to do that. And we really appreciate the partnership together, right? This is a all industry challenge, right?
Oh yeah.
Vendors, utilities, and we all need to step up and help make our system every day a little bit safer. And I'm very confident if we do that and we work together, we'll be able to accomplish those great goals.
I agree. I totally agree. Again, James, thanks so much for your time today. A great conversation.
Thanks, Dave.
Thank you for stopping by Schweitzer Drive. Join us again as we learn about, explore, and celebrate electric power. For more information about the show, please visit selinc.com/Schweitzer Drive.